Hey everyone, if you are enjoying these videos, go check out my website at www.apcsexamprep.com. I have information on boot camps and tutoring availability along with other AP Computer Science resources I think you'd enjoy. Hello and welcome to 1.9 of CodeHS's AP CSA 2025 edition. Today we're going to be going over method signatures. So in the past we've learned about different classes and how a class has attributes and methods. So specifically we're going to be talking about methods today. So we've utilized the main method and we've utilized the string class and utilized methods in that class. But these individual methods have method signatures. And we just went over comments on the Java docs and how to properly document methods, but how do we actually write our methods? So methods are named blocks of code that run when they are called. So it's a specific name for a series of things to happen, and you make them so that you can call that same thing over and over, and it will do the series of steps or the algorithm which you create inside of the method. So add numbers. Hey, add numbers. Can you please add numbers 6 and 49? So the main method could run method 1, run method 2, run method 1 again. So we allow ourselves to break our problem down into smaller steps and be able to repeat parts of it in order to have our program do what we want it to do in a concise and efficient way. So public int add numbers, int A, int B. So this is what a method signature would look like. So you have the access modifier, whether it's public or private. We'll talk more about that in a minute. The return type, the name of the method, and then the parameters. Then within the method, after the method signature is written, you have your block of code, which would be your method body. So your Java docs or comments that are above the method might describe what the method does, the precondition, postcondition, and parameter and return type. So you can also just put a short little description of what the method does. So it adds two input integers together, returning the result. So it would add A and B and return the result. So this is what we just had gone over. Return type, name, parameter list, and then that access modifier, which we'll talk about later. A parameter is a variable that is declared in the signature and can be used inside the body of the method. Moreover, it's the input into the method that allows you to utilize multiple values. When you call add numbers, you can plug in any int value for A, any int value for B. If there are no parameters, that means there's no required values in order to run the method. But it limits, in this case, it would limit what your values are because you're not able to plug in that input to customize what numbers you want to add together. Then the return type is the value that gets returned. So a lot of times you start off by using void methods, which don't have a return type and might simply print the value, which is nice because you can see the result printed in the console, but you can't store that value. It just gets printed to the console and then it poof goes up in smoke. It's gone. So a return type allows you to save that value, so in this case the calculation of adding the two numbers together, and then maybe you might use that later for another calculation or in another method or in an if statement comparing that value to something else, versus no return type. Like I said, it just would be printed or maybe adjusts a value. It's just a command of doing something. It doesn't give you back anything. And then this is visibility. So public means you will have access to it outside of the class in which it's defined in, versus private would mean that it's only available in that class. For this course, 90% of our methods or more will be public, and then our instance variables, which we'll talk more about later, will be private. So then we can use the static keyword, which we'll go over a little bit more later, but that means it's a method assigned to the class versus assigned to an object. So the method signature, what you've just created, is an essential piece in defining a method. The signature in combination with the method's code determine what a method will do. So what will it return? What are the parameters? What's its visibility? What's the name of the method? So the method won't actually happen unless you call it. This method description is just teaching the computer what you want it to do when this gets called. So nothing actually happens, it's just teaching the computer the set of code you want to have happen when it gets called. Nothing will happen unless it actually is called. Hey method, run. So calling a method means running the method, causing it to perform the task that you assigned it. This is done with the method's name and any required inputs. When a method is called, the code block within the method is executed, then the program returns to the point where the method was called. So sum equals add numbers 3, 4. So it calls add numbers 3, 4. The program looks for the add numbers method. Here it is. 3, 4. 3 gets plugged in for A, 4 gets plugged in for B, and it will return A plus B. So the sum will equal 3 plus 4, because these are the arguments getting passed in this call to add numbers. So an argument is a value that is passed into a method's parameter when the method is called. So that value gets returned and literally replaces this method call with what is returned. So 7 would replace add numbers, like so. And you could either store it as a variable, or we could print out add numbers 3, 4, and it would print out 7. Add numbers 3, 4 would be like putting 7 semicolon by itself. So really it doesn't do anything for us, so not something that you'll be doing when you have a return, which is different than when it's void. Sometimes just calling the method by itself would print it out if it has a print statement inside of the method. It's a little bit different with a return. So inversely, if you have a void method and you try to assign sum equal to a void method, well, nothing's getting returned here. So this wouldn't have a value that is replacing add numbers. And you actually wouldn't legally be able to put return A plus B. So the program would have an error, expects you not to return a value, but you do return a value, so that would be a problem. Okay, another thing you can do is not just put in literals, but you could also put in variables to the parameters. So add numbers first, comma second, grabs 8. 8 is in for first, 7 is in for second. 8 first is passed to A, which is 8. Second is passed to B, which is 7. And so we would return 8 plus 7, which would be 15. Okay, so what is the primary motivation of creating a custom method in a program? To make a program run faster by reducing the number of lines of code? Not necessarily, although it might. To reduce the number of comments by using descriptive method names? Also, yes, but not the whole reason. To break down complex problems into smaller reusable pieces. So that's the main point of it. All programs need at least one custom method in order to run without an error. That's not true. So although these are decent answers, it's not the main, the primary motivation. Okay, to break down the complex problems into smaller reusable pieces is the primary motivation. So which of the following method signatures correctly includes a parameter? Well, we have to give a type and a variable name that we're going to use inside of the method. Although when we call this, we're going to put a literal value in when it's called, the parameter is just giving a type and then a name so that it knows what to use when we actually are going through the block of code inside the method body. So which of the following method signatures will correctly return an integer when called upon? So we need an int return type, and none of the others have that. So which of the following best explains the difference between calling a method and defining a method? So calling a method is having it execute, and then defining a method is teaching what the method is supposed to do. So calling a method creates the method? No. Calling a method and defining a method are the same? No. Defining a method is optional? No. Defining a method specifies what the method does, while calling a method executes the instructions of the method. That would be our answer. So, calculator 5, 7, 5, 7. Sum is equal to 12, so print 12. If this works as you would expect it to. Okay, add X, Y, it returns an int type, which is what we want. So yes, it would return 12. Parameters from arguments. So the parameters are the variable values that you will be utilizing. We don't know what these values are because the arguments will determine what these values are. The arguments are what is passed in when the call to the method happens. So this is the call to the method. Hey, computer, add. We'll add what values? Well, first num and second num. First num is 5, second number is 7. Here, the parameters allow us to utilize any int value for x and any int value for y, so that we can do more than just 5 plus 7. We can do any numbers in there that are int values and return the addition there. So in the add method header, x and y are parameters. Yes. While in the call, add first, second, the variables first num and second number are arguments. Yes. Okay. Okay, we want to read through the program carefully and predict the output. Run the program. Was the prediction correct? Why or why not? Okay, 11 gets passed in for mystery number. Since this is not getting assigned to a variable or getting printed, it needs to be a void method for it to really do anything. So it is a void method, and the void method is printing num times 15. Num is the value of the parameter, but what is the argument passing in when the method is called? This is the argument when the method is called, number 11. So 11 gets passed in, and num, this is replacing num here. So this method call would be 11 times 15. Quick math, what is that? 150, 165. So that would be my prediction. It would print 165. There we go. And then you need to change the program so the mystery method now returns the value of the calculation instead of printing it out. See, when we print it out, we couldn't use this answer, num times 15, anywhere else unless we were doing hand calculations, and we see that it's 165. However, int answer equals, and then if we return an int, change the return type to an int return type, and then we actually physically return num times 15. Well, now we could system.out.println answer, and it will print the same thing, 165, but now we have answer stored. If I wanted to do int answer2 equals mystery method answer, now I will do 165 times 15, and I could even print that out for answer 2. So 165 times 15 is what, 2,500 or something? Yeah, so 2475, right? So returns, be sure to adjust. In the main method, the return value of the mystery method is called to the current value of the variable number. Added to the current value of the variable number. Okay, all right, so now instead of that, we're going to say number plus equals answer, and then that is what gets printed, number. So it says the answer, the value returned to the mystery method is added to the current value of the variable number. So this gets added to the current value of number, and then we print it out. So we try that again. That should be what, 165, 176. And then we check that code. So maybe they want us to do this in a shortened step and have all of this in one line. So it would be number plus equals mystery method, and still the answer would be 176. CodeHS just being a little bit picky on how they want it done, and there we go. So build the house, put away the hammers. You're going to build a virtual house using ASCII art. Using 3 method headers provided in starter code, complete the method bodies to create a roof block. the triangle and the sample below. Escape sequence when trying to print certain characters like quotes. Void methods don't return any of the values. Those methods should print their design when called. Build at least 2 houses with different number of levels by calling in the main method. Alright, build roof. I'm not going to reinvent the wheel here. Copy, paste, copy, paste. So I think they're going to include this as the ceiling. So this would be copy, paste, copy, paste. Okay, and then the floor, since it doesn't double up here, I'm going to go ahead and say you're going to leave out the floor and maybe include that on build sidewalk. We'll see, though they're going to probably have an issue with one or the other. So build sidewalk is going to have be part of the floor. It's hard because I don't know which one of these makes more sense. I would say it makes more sense, so I'm just going to do it how I would do it. That part of the roof, and then this part of the floor, and then build sidewalk. And then this is going to be equals. So build roof, build level, sidewalk, and then do the same thing, but add an extra level. See if it looks right. Our test. Yes and yes. See if they like it. All right, excellent. Introduction. Prompt user for 3 pieces of information: name, grade, level, fun fact. Print introduction method, pass in the information as arguments. Complete print introduction method so that it prints out the introduction information as seen in the sample below. Clear the scanners after the int value. Okay, so scanner input equals new scanner. First, we want to have our 3 pieces of information: name, I want to prompt the user, please enter your name. Please enter your grade. Int grade equals input.next int. Please enter a fun fact about yourself. We need to clear the So when we do input.nextInt, if you don't remember, it'll get here and then it'll be waiting right here for the line to be finished. Since int is just going to grab the next int value and then it would, wait right here. If you just tried to make this a string value by itself like we do up here, it would grab the rest of that line, which is empty, and you would have an empty string. So we need to clear it out. Fun fact equals now input.nextLine now will actually be on the next line, which is whatever you enter here. And then they want you to print introduction. And so we would print introduction and we'd put name, grade, and although this is fact, the value that we're passing in here, the argument we're passing here, we named fun fact. So all the compiler really cares about is that this is a string type, this is an int type, and this is a string type. It doesn't read the variable names because there's unlimited variable names you could give. So there's no way they could identify that. I could put in, fun fact as a string, and that would literally be the value of fact. But instead, I'm going to use this as a variable, which will be my answer to fun fact. And so, how do they want us to print this out? Well, system.out.print. They want us to say name :space plus name, this parameter value, and then plus quote. Do we need to do that? No. So we can just do 3 separate print lines. Grade :space plus grade, and then system.out.println fun fact :space plus not fun fact, but just fact, because that's the name of the parameter. Any variable created within a method is only available between these curly brackets, and that includes the parameters. So the parameters, these are not visible, nor would they be understood if you tried to call them out here, and vice versa. Any variable in here that's created is only visible in here and would not be understood in this. The only way that we're able to pass these values that are created up here is because they are our arguments. Okay, and so get rid of these. Get rid of some of this extra space so you guys can see it all. We run it. Tanner, grade 12, fun fact, I like to teach programming. Okay, looks good. See if they like it. Maybe they wanted an extra space in there. The assignment did have a space here, so yeah, they're probably going to get mad at me for that. But we'll see. Nope, looks like they're okay with it, so very good. So overloaded methods. This is when you have a different list of parameters for your method with the same name. So calculate the area of a square has a different formula that's needed than calculating the area of a rectangle. Yes, you could do length and width for both a square and a rectangle, but you can also specify it and just do side squared. The calculate area for a trapezoid, okay, is base 1 plus base 2 times half times height. So each of these would be entirely different, could be entirely different calculations. However, how does the computer know which one to choose? Well, it's based off what arguments you pass in. If you pass in calculate area, when you call calculate area, you pass in if you pass in 3 double values, then it will use this method. If you pass in 2, it'll use this, and 1, it'll use this. So method overloading makes your code simpler and easier to use because all the methods that calculate areas share a common name like calculate area. They're still doing the same basic function. It's just with different values and calculating the area of different shapes in this case. So the programmer and user only need to remember that one method name as opposed to calculate square area, calculate rectangle area, calculate trapezoid area. They just know that calculate area, as long as we pass in the correct parameters, will calculate the area of whatever shape. So you would see it written out a little bit more like this, where public static double calculate area. This only has one parameter. This one has two. I know it's kind of scrunched here. You can see that. And then this one has three. And each of them have different calculations that are happening. Length times width, side times side, and then half base plus base 2 times height. So can you identify which method call is happening with which? Yeah, I mean, they say it pretty much here. One argument, two arguments, and then three arguments for the trapezoid. So you finish the three calculate average methods that calculate an average and return a double value. The first method takes 2 doubles as an input, the second takes 3 doubles, and the third takes 4. To test your methods, write at least 3 print statements, 1 for each method, that call with the correct arguments, etc., etc. Okay, all right. So we're gonna return A plus B divided by 2. Since these are doubles already, they would add together and still be a double, so you can divide by an int value, no problem. And then this would be A plus B plus C. And this would return A plus B plus C plus D. Don't forget to divide by 3, because there's 3 values, and then divide by 4 here, and then write the calls correctly, which is probably the most important part here, is understanding how to call these methods, not just define them. So calculate average 1, 2, should be 1.5, copy, paste, paste, paste. 1, 2, and 3 should be average of 2. 3, 4 should be an average of what? 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, divided by 4 is 2.5. So 1.5, 2, and 2. Did CodeHS want us to do anything different? Storing the values as variables possibly, and then printing them, or are they okay with it just like this? All right, looks like they're good with it. And that is it for 1.9 on CodeHS's AP Computer Science A 2025 edition. Thanks for watching. If you enjoyed this video, please don't forget to like and subscribe, as well as visit my website at apcsexamprep.com, where you can find more information and resources on AP Computer Science A, as well as AP Computer Science Principles, and my introductory to game design in Greenfoot. I hope you enjoyed the video, and don't forget to check out my website, apcsexamprep.com, where you can get more information on boot camps and tutoring availability.